Welcome back to the notes. In this second and shorter part, we will talk about moments of inertia. This is the term that is used in our textbook. However, you may want to know that it is more commonly called rotational inertia these days. And if you take AP Physics 1 or AP Physics 2, I believe this is the term that you have used. Second moment is also an older term that is not used much anymore. So it is written I sub x and I sub y, and it is a measure of the tendency of a matter to resist change in rotational motion. So think about an ice skater rotating around himself or herself. When their arms are extended, they wouldn't rotate that fast, but a typical move is to gradually bring their arms closer and closer to their body, and by doing that they are reducing their rotational inertia, and you can see them turn faster and faster. So for a punctual mass, so if we are not looking at infinitely many points, if we just have one point and we are interested in seeing what the moment of inertia is about a given line, so how reluctant it would be to turn around that axis, the formula is I equals md squared. So the distance from the axis is quite important. And we can see that there is a similarity for a planar lamina. So here we have infinitely many points. We can't just find one, or we can't just add a 2 or 3 like in the early examples in part A. It has the similarity of m would be represented by the density here, times d squared is the distance here from the x-axis. Likewise, for I sub y, it's m or rho times x squared. We are going back to the same triangular lamina, which has a density function rho equals 2x plus y, and this time we are interested in finding the moment of inertia about the x-axis. So we are going to look at how far points on this lamina are from the x-axis, and of course that corresponds to the y-coordinate of each point. So y squared times rho of x and y, and we end up with a polynomial. So just like before, it is not very difficult to calculate once we've set up the equation, and eventually we reach 54. So you might be intrigued by the units here. I think this is just an example, but it would be, if we look at the formula for punctual masses, it's the mass times the distance squared. So the units might be kilos times square meters. There's only 2 exercises left in this section, and they are both related to moments of inertia. It's question 27 and 31 on page 1018. Please ignore these symbols here. This is actually related to what is called the radius of gyration. It's the idea, or it's the answering the question, if the entire mass that we are studying was located at one single position, what would be the distance from the axis? So finding that would give us this singular location where the entire mass could be, rather than being spread around the entire planar lamina. But we are not doing that. Thank you so much for listening.